Okay, now we're live.
Okay.
Couldn't get it to work.
Hello, world.
Fingers. Okay, so did anyone have any specific questions?
I think I did the whole central limit theorem. I'm just curious as to why it is so important, like she talked about in the announcements, you know?
Yeah.
Curious to see just what effects it will have.
Mm-hmm.
But otherwise, like, I don't think I have any particular questions based on the assignments.
Yeah, it was kind of all straightforward for the most part.
Yeah. I don't have any either.
My little guy.
Sorry.
Oh, not a problem. Gotta do what you gotta do. So should I go and just jump into the test, the quiz?
Yeah.
Yeah, I think so.
So you guys see that we have our first test next week.
Yay.
I'm just really curious, is it going to be like these quizzes, or is it all of a sudden going to be like, oh, remember those concepts that we didn't really do anything with about were in the textbook?
Yeah, all that stuff you skimmed over because it wasn't needed.
Yeah, we're now dropping several intense questions on those formulas and things, and so I guess we'll see.
Okay. Yeah.
Okay, mine's just about loaded.
Yeah, mine's up.
Okay, I'm here.
Up.
Okay, so question 3. When
Yeah.
you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
Should be skewed right?
Where if it's just the n equals 5, that's it. So yeah, then skewed right.
Because if it's skewed right and it's a small sample size, it'll reflect it, right?
Yeah.
Right. It's only when it gets bigger that it starts becoming more
Normal.
like a bell curve.
Which is the next question. When you're taking sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed?
It should be normal.
Normal.
Yeah. When you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed?
Should be normal again, right?
Yeah.
Because if it's normal, it'll be normal.
Yeah.
When you're
You're taking a sample size of n equals 100 and the shape of the distribution means histogram. Wait. When the parent population is normally distributed. So that would also just be normal.
Normal.
Something we're missing here?
That's the thing. Like, I thought it was pretty simple as far as if it's skewed right and it's small, it'll be skewed right. If it's normal and it's small, it'll be normal. If it's normal and it's big, it'll be normal. If it's big, it'll be normal all the time.
Yeah.
Like, I don't know. That's why I worry that I'm missing something because it seemed really simple, but they were putting a lot of emphasis on it.
I guess we'll find out.
Right.
That we will. So when would the distribution of means be normally distributed? The data are drawn from a population that is normally distributed with the sample in small, so that'd be 1.
Yes.
Data are drawn from a population that is normally distributed large. Yes.
That would be 1. Data drawn from the population that is right skewed and the sample size is small.
Nope.
No. Data drawn from the population that is right skewed and the sample size is large. Yes.
Yeah.
There should be 3 checked, right?
Yeah.
So everything except for the third one.
Yeah.
Okay, number 8. Which of the following gives the best explanation of the central limit theorem? The first one says, if the parent population from which the data is drawn is normally distributed, then the sample mean will follow a normal distribution. Or the second one says, for a bell-shaped data, approximately 6, that's not 8, that's the 68, 95, 99.7 rule.
Yeah.
If the sample size is large, then the sample mean will be close to the population mean. Or if the sample size is large, the shape of the distribution of the sample means will be approximately normal.
I want to say it's 3 or 4.
I would say 3, 4 is the law of large numbers. No.
Oh, true.
Or did I get those backwards? Because one was about accuracy, and the other one was just about
The sample means.
sample means. Where it is? I have it pulled up. The central limit theorem states that if the sample size is large, the sample mean will be approximately normally distributed.
Isn't that the first one?
I think so. The law of large numbers says the sample size increases, the standard deviation will get smaller. Oh, yeah, so law of large numbers is the accuracy, so that'd be number 4.
Okay.
Whereas the sample
So,
mean will be
I think it's the
approximately
first
normally
one.
Alright, let's go with the first one.
No, because that one says if it's normal, it'll be normal. That one, the thing was saying if it's large, it will be normal. Well, I don't know. Yeah, I think you're right. I think it was the first one.
This one
I'm second guessing myself.
is-
Let X.
Yeah, no, because it does need to be the sufficiently large. Not, it doesn't talk about the size of it at all in the first one. You're right. Hmm.
And I guess the issue is because they use the X bar X or whatever.
The sample mean.
We're still on 8, right?
Yeah.
Yeah.
Okay. Just wanted to make sure.
I don't know. It's 1 or 3. The data is normally distributed.
Are you sure it's not 4?
Maybe it is.
Let us read over this section again. So,
I think it's the fourth one because I'm reading in the textbook about the central limit theorem, and it says, blah blah blah. The sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large.
Yeah. So you're right. It is 4.
okay. 9. So you let X be random variable with the population mean of 10 and population standard deviation of 6. Both sample mean of 36 is drawn from this population.
So the mean would be 10.
Wait.
Nice stuff just froze. Oh, there it is. So the mean would be 10, right?
Yeah, wouldn't it just be 10?
I just feel like that question is too easy because it literally
My
says
stuff is freezing.
the population, like, you know, this is the mean.
But there's like no other way to solve for it, right? Like,
Sorry, I froze up. Well, you guys are still on number 9?
Yeah, we are.
The
Because
mean of the sample means is the U, so it's 10.
Yeah. Yeah, the means are equal.
Yeah, so it has to be 10.
All right, 10.
What is the standard deviation of the distribution of sample means?
So that one is standard deviation divided by square root of the population.
So that means divided by 6.
6.
So 6 divided by 6 is 1, right?
Yeah.
1.
So it would just be 1. Regardless of the distribution of the population, if the sample size is large, n is greater than 30, what would be the shape of the distribution of the sample mean?
Normal.
Normal. What theorem would you use to justify the last question? Central limit theorem, right?
Mhm.
For sure.
That's it? Okay, well,
Do you want to have? I'll go ahead and submit it,
okay.
and then we can go through what is right or wrong there. Let's see. I'll scroll to the bottom. Yeah, 100%.
Cool.
Nice.
Yeah, it's. I guess it's
I
just
love it.
defining the difference between the large numbers and the central limit and making sure that they're different.
If I remember correctly, one of the videos talked about that.
Yeah.
I can rewatch that.
Yeah, me too. Because I thought I had it until that one question number 8, where I was like, well, maybe it's this one, or maybe it's that one.
Right?
So, but yeah, other than that was quick, fast, and easy.
Yeah.